Hey everybody, Kyle here with Spicer Designs. Oh, damn it. Welcome back to the channel. All right, so you can see here, I have 3 of my main pieces of metalworking equipment that I use in my shop, and they all have one thing in common. First, we have the vevor TIG 210P TIG welder. This is a dual voltage TIG welder. I can weld on 120 volt, but ideally to get the full use and the full ability of the machine, it's ideal to run on 240 volt. Next, we have my trusty MIG welder. I use this all the time. This is a great welder. This is the Hobart 210 MVP, and this is also a dual voltage machine. And then last, and probably the most important, is the Langmuir Crossfire Pro CNC plasma table. And this has the Razor Weld Cut 45 plasma cutter. This is not dual voltage, so I definitely need 240 volts to run this unit. Now, all 3 of these units require the same 240 volt outlet. This is a 50 amp, 240 volt NEMA 6-50R receptacle, and I will be installing this today on a 30 amp breaker. Now, like always, I will have links for all 3 of these machines down in the description below, and I will have discount codes for the Langmuir Crossfire Pro plasma table. Now, 30 amps of 240 is all that I really need for the machines that I'm running, but this receptacle is capable of up to 50 amps. Now, what I'm going to be doing here today is just a temporary setup for being able to run these machines. As some of you may know, we are out here in the new Spicer Design shop. I have not started this build out quite yet. So if you do want to see this build out progress, make sure you hit that subscribe button so you can follow along. For all of you that don't know, I am an electrician by trade. I've been an electrician for over 18 years, so I do know what the hell I'm doing. Now, whether this is a temporary or permanent solution for you to get your machine up and running, what we're going to be doing today is installing this 240 volt receptacle as close to the panel as possible. Now, even though it's temporary, this still may be a very good permanent solution for you as well because it saves you some money. The closer you are to the panel, the less wire that you have to use. And when you get into a higher amperage receptacle, the wire sizes get bigger. And when wire sizes get bigger, they cost more money. So the closer you can be to the panel, the less money it's going to cost you and less labor. Now, full disclaimer, if you are not an electrician, I highly recommend that you hire a certified electrician to do this job. But if you are a DIYer and you want to take this job on yourself, always make sure you follow local code requirements, take all safety precautions, check for zero, safety glasses, gloves, take every precaution you possibly can. If you get hurt or hurt someone else, get shocked, electrocuted, burn your house down, I am not liable for that. That's on you, my friend. All right, time to get started. We've got our safety glasses on, check. We've got our gloves. Ooh, that doesn't smell right. Number 1, very first thing, very important. Not everyone's barn or shop is the same setup. I have a 200 amp panel out in my shop. Not everyone has that. So I know that I have 240 volts available right here very easily. Now, if you do not have 240 volts going out to your barn, shop, or garage, you are f***ed. Well, you're not f***ed. You're just gonna have a little bit more work and time and money that's gonna have to go into that project. Number 2, let's get this panel cover off. All right, we got our panel opened up. It is energized right now. When you're able, it's always a very good idea to shut the panel off when you're working in it. I am not going to do that today because I know what the f I'm doing. Ah! Spray foam, that's good. Spray foam's good. All right, now that we have full access to the inside of that wall where we can run all of the wiring that we need to, let's talk about what material we're gonna be using to get this job completed and some other possible options that might work better with your setup. All right, the first thing we're gonna talk about here is the wire. There's a couple different ways to do this. You can either run conduit and run individual conductors inside of the raceway, or most people are probably gonna use Romex. Being that this is temporary, I am going to be using Romex, but Romex is also a permanent solution as well. But when I do the build out, I will be running conduit in the shop. So what we have here is a 3 conductor number 8 gauge wire with a bare ground. This is a Romex, and this is going to be the easiest thing for us today to just route that short little piece. Now, as far as wire sizing goes, we are going to be using a 30 amp breaker today, and just a general rule of thumb in residential and commercial is 14 gauge wire is good for 15 amps, 12 gauge wire is good for 20 amps, 10 gauge wire is good for 30 amps, 8 gauge wire is good for 40 or 50 amps, and number 6 gauge wire is good for 60 amps. Anything higher than that, you probably want to get an electrician involved. Now we're going to be using number 8 gauge wire today, even though it's going to be on a 30 amp breaker. It's always okay to increase the wire size on a lower amperage breaker, but you never want to do that in reverse. You don't ever want to increase the breaker size to a higher amperage on a lower rated wire. Basically what will happen is the breaker has no idea what size wire is landed on it, so it will pull the current that it needs through a wire that is undersized. It'll cause that wire to heat up, and those are the kind of things that start fires. Next thing we're going to talk about is the box. There's two different options we have here. We have a flush mount setup, and we have a surface mount setup, and we have a piece of setup. What we're going to be doing today is a flush mount setup. So what we're going to be using for that is a 1900 or 4x4 bracket box. This is a deep bracket box. There are shallow ones that are about 1.5 inches or 1 5/8 deep, and then you have the 2 1/8 inch deep. So the deeper the better, because we've got a larger receptacle and there's going to be heavier gauge wire. The deeper the box, the better. Now along with this 1900 bracket box, we are also going to be using a 1/2 inch mud ring. This is a 2-gang mud ring. This is something that you use on drywall or any kind of wall covering. So this is going to mount to the 1900 box, and then we're going to go ahead and put our wall covering over that, and we'll cut the opening out. Once we have this installed, the wires in the box, we can then trim out our receptacle and put our flush mount cover plate on it. Your next option is going to be a 1900, we call them bald boxes, but they just have no brackets on them. And in this situation, you would maybe stick your cable through the wall. You can come into the back of the box with a connector, and this box would mount right on the surface of the wall covering. And the trim plate setup they're going to use for that is what we call a Garvin cover. Your welding receptacle or any kind of receptacle you're using would fit through this, and then it would mount to the front of your bald box. All of that stuff would just be exposed on the outside of the wall covering versus the flush mount. Now if you're really on a budget and you want to do it really half-assed, you can use one of these crappy plastic boxes. I don't recommend using these, especially when you're putting in a larger welding recep like this. And the reason for that is these things are kind of flimsy, and when you're trying to push a large receptacle into here and you're plugging it and unplugging it, these steel boxes are a lot beefier, and beefier is always better. Love that beef. So that's going to cover the rough-in setup. Now when you run that cable, we're going to be using some take-all style connectors, and these are basically a multi-use connector where you can have different size Romexes. You can get them in 3/4 or 1/2 inch. And then of course, we're going to have our 2-pole 30 amp breaker that we're going to use for this. Now the style breaker that you're going to need is going to depend on what kind of panel that you have. So make sure you check out the other breakers, see what type breaker they are, and you're most likely going to be able to find whatever breaker you need at your local hardware store, Home Depot, Menards, Hobby Lobby. Maybe not Hobby Lobby. All right, that's that. Let's continue with the installation. All right, like I said, we're going to keep this thing mounted nice and close to the panel. And you can see I've got an outlet right here already, and what I'm going to do is just mount this one just right below it, just so they're kind of in line. That way if I move a cabinet or something over here, I'm not going to want to block this outlet or this one. So I recommend prepping the box first, get your connectors in there. Best thing to use for that is a pair of needle nose pliers, works pretty well. Then we're going to take our take-all connector and screw it into the 3/4 knockout. Jeans. Damn it. I'll have to cut these into some short shorts. All right, now that we got that box mounted, we're gonna wanna get our 3/4 connector into the panel now, and then we can run that wire. Now this setup's gonna be a little bit different. I got that knockout punched, but I won't be able to access the screws to tighten the Romex. So what we want to do is put the connector on the Romex first, we'll push it through, and then we can put the lock ring on it. Where the f is that connector at? Damn it! There it is. So what we're going to do is cut a chunk of cable off right now. If you got a little extra, who gives a shit? All right, now that we got this cut, the easiest way to do this, kind of get an idea of where you're going to put that breaker. We're going to put it right here on the top right. So I know that I need pretty much about a couple of feet in there. So what I'm gonna do is I'm gonna strip this out now so that I don't have to do it inside the panel where it's a little bit more dangerous. So I use a razor blade and I'll lightly score the jacket on this. You don't want to cut all the way through. If you lightly score it, you can lightly break it, and then that outer jacket will just kind of split on its own. To do that, you should be able to slide it off. All right, now that we got that stripped out, we're gonna pull the lock ring off the connector, and then we can slide this take-all connector right over your Romex down to where it meets your jacket, and then we can go ahead and tighten that up. Now we can slide this thing into the panel. Like I said, the safest way to do this is to always shut the panel down. All this shiny bus right here is all energized. Just kind of fold this down out of the way, make sure it's clear of any of this live bus. We're gonna make these connections last. It's just a safer way to do it. We're gonna make all of our field connections first. All right, now we're gonna take the other end of our cable that's gonna go to our new box, and we're just gonna kind of dress this in a little bit so we can size it up and trim it down. So something like that looks good. We know that we probably want it to be somewhere around here. I always like to have a good 8 to 10 inches of wire in that box. It's always safer to trim it down more than not have enough. So we're gonna go ahead and cut it right here. Once we have it trimmed to length, we can go ahead and put it back up here again, and we just want to come in about a ½ inch into the box. Then we can score the outer jacket and strip this off. All right, once we got this stripped, we can slide it in our box now. It's also not a bad idea just to secure that cable. All right, now that we got this wire in the box, we're gonna go ahead and just kind of tuck it in there. And then we're gonna throw our 2-gang mud ring on this. And now we are ready to put that wall covering back on. We'll obviously cut this hole out. Then we can install the new receptacle, put the cover plate on, and we'll go ahead and trim out the panel. On a side note, this loose outlet is bad. This was not installed correctly. I do have a video where I show you the right way to install an outlet. I'll leave a link down in the description. F***ing hillbillies. All right, now that we got this wall covering back on, this is just temporary. Eventually I'm gonna pull all this out anyway and redo it with a wainscoting. But now we can finally start installing our welding receptacle. Now, if you did watch the loose outlet video, I basically show you how to install an outlet correctly. What happens sometimes is the mud ring or the face of the box that you're mounting your device to sits in a little bit further than the wall covering does. So we use this harder rubber tubing to basically make up the difference so that you could securely mount your device without it getting loose over time. All right, now we can trim this thing out. We're gonna pull our wires out. We have 3 wires here. We have a black, a red, a white, and a bare ground. Now this welding receptacle only requires 2 hots, the 2 gold screws, and the ground. It doesn't matter which one of these gold screws that either one of these hots goes on. It's a single phase system. There is no rotation. Whichever one we hook it on, it'll work the same either way. Now the white wire is going to be an extra wire. I always like to pull a 3 conductor for any kind of 240 volt setups. Every once in a while you run into something that does require a neutral. So it's always safe to have. Worst case, you at least have an extra conductor in there. So what we're gonna do with that one is we're gonna put a wire nut on the end of it and just keep it capped. And we're gonna tuck that one in the back of the box. Now the very first thing you wanna do when you're working with Romex and a metal box is you want to make sure that you ground that metal box. So we're going to put a ground screw in the back here. There are designated ground screws. They are a green, I believe they're a 1032 or 1024. They have a little bigger head on them so they can get better coverage on that conductor. There is a designated spot to install a ground screw in every metal box. Once we have our ground screw just started, we're going to take that copper wire and we're just gonna wrap it around it, And then we're going to take our strippers and we're just going to pinch it together like so. And then we can tighten it up all the way. I always recommend using a hand screwdriver. If you use an impact or a drill, you could potentially strip something, and it's not really recommended when you're installing devices. Now we're going to insert these underneath the gold screws. You always want to make sure that you strip out enough of that jacket. You don't want that screw to compress down on the outer jacket and not make a good connection with the copper. Usually you can kind of look in there and you can see that the screw actually got into that copper. Now we'll stick our ground conductor in there and get that tightened down. Anytime you have a bare conductor in a box, you always want to make sure that you're tucking your wires in kind of strategically. You don't want that bare copper wire to touch one of those hot terminals or these screws, because obviously it will pop and it'll short that circuit out. Now, one thing I like to do when I'm installing these welding receptacles is to make sure that I orientate it in a way where the 90-degree plug has the cord going down. Obviously, you don't want it going up where it's then has to turn over. So we're gonna leave the ground up in this case. Now, like I mentioned, you can see between the wall covering and the box, there is a slight gap right there. So we're gonna be using this tubing right here, and we're basically going to cut that tubing just slightly bigger than that gap, slide it over the screws that mount it, and then as we tighten them down, it will compress that tubing and allow us to secure that device so it's flush with the wall covering. Another thing you want to make sure of is when you're screwing these mounting screws in, you want to make sure that there's not a conductor right behind it where that screw can pierce that jacket, because that'll cause a dead short. You can see I have the outlet now tight against that tubing that I just put in there, and being that it is kind of a harder rubber, as I screw it in more, I can get it right to where it sits nice and flush with the face of that wall covering. All right, now that we got our welding receptacle nice and secure, we can go ahead and throw our stainless steel cover plate on there. You can see it all fits up real nice and tight along that wall covering. Now, a good craftsman always leaves his screws in the same direction. I prefer vertical. All right, now for the dangerous part. Now you can see why it makes sense to make these connections last. If we were to make these connections on the breaker, maybe we walked away for a minute or two, there's other people on the job site, someone could potentially turn that breaker on, not knowing what it was, and then you come back to trim this outlet out and it's energized. It's always a good idea to make those field terminations first, then come back and trim out your panel. All right, just like the welding receptacle, that extra white wire, realistically we could land it on the neutral bus, it wouldn't hurt anything. But since we don't need it, I'm just gonna cap it and I'm gonna tuck it in the panel. Next thing we're gonna do is install our breaker. Now, all of these residential breakers pretty much mount the same, especially on newer panels. But the first thing you wanna do is make sure that the breaker is off. Because if you install it on that live bus and it is on, you're gonna energize these screw terminals here on the side, and the way you're holding it, you could end up getting shocked. It's gonna hook on the outside, and then you're gonna push it in right on top of the bus. Next thing we're gonna do is we're going to terminate this ground wire. This panel is a first means of disconnect, so it does have a bonding screw in it. In that case, we will be mounting our neutrals and our ground wires all to that same neutral bus. Definitely use extra caution when you're mounting a bare copper conductor like this, because if it touches something energized, it's gonna arc in your face. All right, all that's left is to land these two hots. Typically starting at the bottom of the panel or the top, you're gonna alternate phases, black, red, black, red, black, red, black, red. It's more for a reference than anything. So we're gonna form our black wire in here, and then we'll turn it over. We can kind of get an idea of where we wanna cut it. Go ahead and cut it, strip it out. Now we can form our red wire in there. Now, once you have your breaker installed, make sure that that copper is underneath that compression lug there. And you don't want to have too much copper sticking out, because it just kind of creates a hazard. Now, when you go to put that cover back on the panel, you're going to want to make sure that any wires in here are all tucked to the back of the panel, because when you put those panel screws in there, those screws can go through and they could pierce the jacket on one of those conductors and cause a dead short. All that's left to do is to knock out these spaces and your panel cover to accommodate the new breaker. You can put that panel cover back on and get everything labeled. We're all cleaned up, ready to fire this thing up. This job is not complete until we test this circuit. So we're gonna go ahead, turn this breaker on. We're gonna use our multimeter to check for voltage. Looks good. Now for the moment of truth. Let's plug this motherfucker in. Will it work? Yes! Finally did something right. See, Mom? I'm not a failure. Just kidding, Mom. All right, that is going to wrap it up for today's video. We are one step closer to getting Spicer Designs up and running. I could finally get these machines fired up, and start doing some welding and plasma cutting. If you are going to take on this project yourself, please use every precaution possible. And if you don't feel comfortable doing it, call an electrician. Like always, I will leave links for all these machines in the description, along with Amazon links for some of the electrical material that we used here today. The most critical one probably being that 50 amp welding receptacle. One thing I did at our last shop was I made this welding extension cord right here, where I've got a 50 amp male end and a 50 amp female receptacle right here. And this is about 20 or 25 foot long. So the placement on that welding receptacle is not super critical because I can use that extension cord and I can basically use the machines wherever I need to in the shop here. So if you liked this video today and you found it helpful, all I ask is to please hit that like button. It helps the channel and helps get this video out there for other people to see it. And if you want to follow along with what we're doing over here at Spicer Designs, make sure you hit that subscribe button. Thanks for watching. We'll see you in the next one. I need to get my beer fridge out here. We are going to be using this, damn it, and bring the outlet out flush. Damn it! We're going to be welding, we're going to be TIGging, we're going to be plasma cutting. Hope I remember how to use this thing. Let's watch one of my old videos.